Welcome back, seventh grade scholars. I'm Miss Whitaker, and I'm excited to have you guys join me for another math lesson. Let's get started. This is week 4, day 1, and today we're going to discuss SOL 7.10a. What are we doing today? Today we will learn how to determine the slope m as a rate of change in a proportional relationship between two quantities given a table of values. We will also learn how to write an equation in the form y equals mx to represent the relationship. The materials needed for today's lesson: you need a pencil, paper, and the Desmos calculator. This is the link that will take you to their website so you can bring the calculator up on your desktop. So let's talk about some vocabulary words. Slope. The slope of a line is a rate of change, a ratio describing the vertical change compared to horizontal change, the constant ratio of y to x. So in our examples, we have slope represented in several different ways, one being in a graph, rise over run. You have the formula delta y over delta x, which means change in y over change in x, which is also representative of rise over run. Proportional relationship: when two quantities x and y vary in such a way that one of them is a constant multiple of the proportional relationship: when two quantities x and y vary in such a way that one of them is a constant multiple of the other, the two quantities are considered to be proportional. So in our example, we have several different representations of a proportional relationship, one being a graph, another being a table, thirdly being an equation. There is a fourth way to represent a proportional relationship, and that is to use words. Origin. On a two-dimensional graph, it is where the x and y axis cross. So if you remember from 6th grade, when you learned about the coordinate plane, then you know you have a vertical axis, which is your y-axis. You have a horizontal axis, which is your x-axis, and where those two meet is called your origin. Okay? And that represents the ordered pair of 0, 0. Rate of change. A rate of change is a rate that describes how one quantity changes in relation to another. So when you're talking about rate of change in terms of slope, it's talking about the steepness of the line. So rate of change describes the steepness the steepness of the line, how x is changing in relation to y. Multiplicative relationships. When two quantities x and y vary in such a way that one of them is a constant multiple of the other. So if you look at your table of values, x is being multiplied by 2 to get y. And that is happening for all of the values, all of the x values in the table. Y results from x being multiplied by 2, or y is equal to 2x. If you notice, the definition for multiplicative relationships is almost identical to the definition for proportional relationships because they represent the same thing. A multiplicative relationship is the same as a proportional relationship. Y equals mx is the equation of the line where x and y are directly proportional and m represents the rate of change. So if you look at our example or our diagram, it breaks down the equation. Y is equal to mx. Y and x are variables that describe a specific point, and m represents your slope. X is also called your independent variable, and y is called your dependent variable. Y is dependent upon what X is because M will not change. It is a constant rate of change. So whatever you multiply X, when you multiply X times M, you will get Y. All right, let's talk further or discuss further what proportional relationships are. So a proportional relationship is when Y is directly proportional to X, which means that X and Y increase or decrease at the same rate. The ratio between X and Y will always stay the same, and the constant value of the ratio is represented by the letter K. In SOL 7.3, we discuss K in our ratio tables. Okay, so this is the same concept. As I said earlier, you can represent proportional relationship in several different ways, one being a graph. But when you're talking about a graph and whether or not it represents a proportional relationship, there are two characteristics that the graph must have in order to be considered a proportional or in order to represent a proportional relationship. Number one, the line will be straight, and secondly, it will go through the origin. If you have points on a graph and you connect them and they do not create a straight line, then that relationship is not proportional. If you do have a straight line but it does not go through the origin, once again, that is not considered to be proportional. So your graph must have a straight line going through the origin. Okay? So in terms of proportional relationships represented in tables, the table of a proportional relationship will have a constant rate or will have a constant between the X and Y values of that table. Meaning, square feet of carpet versus total cost in dollars. All right, so one is your X and one is Y. So if X is directly proportional to Y, then what is K? In order to find K, all you do is divide. Once again, these values, X and Y values, create a ratio. The ratio between the two will always stay the same. Meaning, to compare X to Y, you would divide 10 over 15, which is 0.67. Okay? So K is equal to 0.67. That is your constant, and that will be the same for all of the relationships between X and Y in the table. 20 divided by 30 is 0.67. 30 divided by 45 is 0.67. You can check it with your calculator. So let's move on to what is slope. Slope is the steepness of a line. It describes the rate of vertical change over horizontal change, more commonly known as rise over run. So if you look at the graph, rise represents the pink arrow, represents your vertical change, and run represents your horizontal change. And when you connect those two, it creates a line. Okay? So in that creates the steepness of the line. That is your slope. So Slope is denoted by the variable m and can be described as rise over run, delta y over delta x. Delta, that triangle you see, means change in. So basically it's saying the change in y over the change in x. And then also you can use the formula y2 subtract y1 over x2 subtract x1. So again, a change in y over a change in x. And then lastly, I want to point out again, if the graph is a proportional, represents a proportional relationship, then you have a line that goes, a straight line that will go through the origin, which happens here. So let's practice determining the slope and also writing an equation in the form y equals mx. Okay, so again, there are two ways, two methods you can use to find the slope. Number one, use the formula delta y over delta x, which is change in y over change in x. So look at the table to determine how the x and y values are changing, then use the formula to find the slope. So let's do that. So what you're going to do is you're going to look at your y values and you are going to determine how are they changing. How can I go from 22 to 44? All right. So you can add 22 to get to 44. 22 plus 22 will give you 44. And if you did not know that, you can work backwards and you can subtract 22 from 44 to figure out what you're actually adding. So to go from 44 to 66, again, you would add 22. Go from 66 to 88, you will also add 22. So let's figure out how the x values are changing. To go from 2 to 4, you would add 2. To go from 4 to 6, you would add 2. To go from 6 to 8, you would add 2. Okay? Now, after you do that, you are going to use the formula change in y over the change in x. So my change in y was 22 over change in x, which is 2. So 22 over 2 will give you 11. And that is our slope. Okay? So now we are going to practice writing an equation that represents that relationship. So we're going to use y is equal to mx. So we are going to replace, all you do is replace m for the slope that you found. And our slope was 11, so you replace m with 11 and write the rest of the formula. And that is all. So our equation to describe this relationship is y is equal to 11x. You can substitute x. If you substitute x with any of the x values, you should get the corresponding y value, meaning 11 times 2 11 times 2 will give you 22. 11 times 4 will give you 44. Okay, so that equation represents the relationship. Let's try the second method. Use two consecutive x values and two consecutive y values from the table and use the formula to find the slope. So consecutive means back to back, one right after the other. So if you're going to say that 22 is equal to y1, you say y2 is 44, it must be back to back. Then that means x1 will be 2 and x2 will be 4. Okay. Then after you label your values, all you do is fill in the formula. So y2 is 44. Subtract y1, which we said was 22, over x2, which is 4. Subtract x1, which is 2. 44 subtract 22 is 22. And 4 subtract 2 is 2. Okay? Which is equal to 11. So 11, once again, is our slope. So we are going to write the equation y equals mx. We are going to replace m for the slope, which is 11, and then finish writing the equation. All right, so at this point, you are going to attempt to solve these two problems on your own. Take about 5 to 6 minutes to solve them. You're going to pause the video and then you're going to hit play when you're done so we can go over them together. Okay? So, once again, we're going to use the two different methods to solve the examples. So, method 1, change in y over change in x. 15 to 30. How is your y values changing? You can add 15. They're increasing by 15. Or it's increasing by 15 between these two values. And then x values, 2 plus 2 will give you 4. If you notice, the y values and the x values are not changing by the same value. 30 plus 30 gives you 60. And 60 plus 90 gives you 150. 4 plus 4 will give you 8. 8 plus 12 will give you 20. However, that doesn't matter. If this is a proportional relationship, the ratio between x and y will not change. It will have a constant rate. So you only need one change in y, one change in x to find your slope. So change in y will be 15 over 2, which is equal to 7.5. And that is our slope. But if you want to check, you can put in your calculators. 30 divided by 4 is 7.5. 90 divided by 12 is also 7.5. So the slope doesn't change, even though the y values and the x values are not increasing by the same value. The constant between the two, which represents the slope, will not change because this is a proportional relationship. All right. Method number 2, Use two consecutive x values or two consecutive y values, and then fill in the form. So once again, we will label. This will be y1, y2, x1, x2. Okay. Then we're going to fill in the formula. So that means 30 subtract 15 over 4 subtract 2, which is equal to 15 over 2, which is equal to 7.5, which is M. So, oh, so to write our equation of the line that represents this relationship, we are going to substitute M for our slope, which is 7.5, and finish writing the equation. 7.5 times X should give you Y, and it represents, you can check it, 7.5 times 2 is equal to 15. And then I forgot to do that part at the top. So once again, you substitute your slope M for the value you found, which is 7.5 X. All you do to write the equation is substitute your slope for M. Okay, now, students, we have come to the portion of the lesson where it's time for you to practice independently. So what you're going to do is you're going to take 10 minutes or so to solve the next three problems. I have added the formulas for you. You can use whichever formula you would like. If you notice from our examples, we used two different methods, but it was the same table. I did that because I wanted you to see that it does not matter which method you use, you should get the same slope. So you should use whatever method comes easiest to you. So you're going to complete 13, 14, and 15. And you're also going to write or find the rate of change of the line represented by each table, and then also write an equation in the form y equals mx. When you are done with that, you are going to complete two green box lessons, and you will be done for today. You try answers will be displayed in tomorrow's lesson. Alrighty, see ya tomorrow.